In this video we're going to talk a little bit about our new instruction set architecture, and we're also going to see how we implement our addressing modes. So that sounds all very grandiose, but it's not. It's something quite simple and straightforward and common sense, as you'll find most of the CPU design is. So let's have a look. And if you open up the file in the resources section, which is the Logisim CPU, and then you can head down into the motherboard, and if we head into the CPU, and then we'll go into the control section. So give me a little minute just to set this up so that you can actually see it. So we shift the whole thing up a little bit because we want to get to the bottom of this here. So you can see here that we have our instruction in. Okay, so this is really our instruction register. Now, previously our instruction register was only 8 bits, and I did mention in a previous video that we would try to maintain a backward compatibility with the simple 8-bit instruction. But I decided against that. It was just too restrictive, and in the end, if we wanted to, we could always emulate the 8-bit machine on our new fast super 16-bit machine. So I decided to redo the instruction set. Now, the basic architecture here has changed. We've now got 16 bits that we can use, and we've got lots of different ways we can use those 16 bits. Now, of course, we have to have a certain number of bits set aside for opcodes. Now, I've set aside the most significant 6 bits over 16 bits for our opcode, and you can actually see it here if I reset this here, and we'll go down in here and we'll actually make the changes. So the most significant 6 bits are here, so I'll change these to a 1 here. I can get them actually 1, 1, 1, 1, 1, and the final one here. So that's the 6 bits, and you can see these 6 bits here going live. Now, these 6 bits feed into our microcoded ROM, and they provide the starting position for, they provide the actual opcode. So actually when they get in, they're going to go into the compression ROM, and they're going to provide the starting position for that particular instruction. So if I've got 6 bits, I've got 2 to the 6, which is 64. So we can have 64 individual instructions, which is plenty for us. It's more than enough. Now, as I mentioned in the last video, we now have 4. We have another 2 bits we use for the instruction mode, and you can see here, if you maybe just make it out, it says AM1 and AM0. So this is an addressing mode, addressing mode 0 and addressing mode 1. So we've got those 2 bits, which will give us 4 possible addressing modes. So for each of these address opcodes here, or each of these instructions, each of the 64, we're going to have another 4 for each of them, which will be our addressing modes. So this is at the moment is an addressing mode 0, and then we'll have addressing mode 1, addressing mode 2, and then addressing mode 3. So this chooses our addressing modes. Now, the thing that's different here now is that I've kept the same basic architecture as far as the registers are concerned. So remember, we had our register A and a register B. In our little 8-bit machine, we had 2 bits for register A and the very last 2 bits, the least significant bits, were for register B. But what I decided to do was to keep that 2-register architecture. And I decided to take the last 8 bits and split them into a group of 4 bits and a group of 4 bits. And this gave us options to access 16 different registers. And you can see here that we're going to have all of our sets up one side and all of our enables. And if I'm able to just shift this over a little bit so you can see. So we're going to have all of our, this one here, that's us. We're going to have all of our sets along the right hand side and all our enables along the left hand side. But if you look and see the number of actual registers we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So there's 17 here. But of course there's one of them actually I've set out that that you don't have access to via the register RA and register RB, okay? And I'll talk about that just in a minute. So in effect we've got 16 different places that we can access in our CPU, or 16 different registers. So it means that this register A, we can refer to all 16 of these individual registers. And also our register B, which is the least significant bits, again we can refer to all 16 registers. So that means in effect, if we generate this opcode and then the instruction mode, and then if we were to say register R0 and register R1, then we can say that the register R0 can talk to register R1. In fact, the register R0 can talk to all of the other registers. And in fact, all the registers can talk to each other. So we have in this setup a very general purpose machine. And I set it up like this deliberately so that we can generate as many different types of addressing modes as we really so desire, and we can generate some really nifty and funky instructions. Of course, we're not going to be using all of them, but we have the option of doing that with this architecture. Now, if you wanted to, you could adjust the instruction set architecture. You could adjust the architecture so that, for example, you maybe had 5 bits for your opcode, and maybe you didn't have any addressing modes, and then you could maybe use 3 bits for a register A, 3 bits for a register B, and 3 bits for a register C. So you would have 3 different register groups that you could talk to between one another. Now, the reason for doing that might be that if you had, for example, a command add R0, R1, R2, then you would be adding the contents of register R0 and the contents of register R1, and you would put the answer into register R2. So this would give you the added advantage that you wouldn't be overwriting any register. Now, we don't have that, okay? We don't have that advantage. I gave up that advantage in order to generate a CPU that gives access to loads of different registers and loads of different addressing modes. So whenever we work through this process, we're always going to be overwriting. So if I had an add R0, R1, you're going to add the contents of R0 onto the contents of R1 and store it in R1. So whatever was in R1 would be overwritten. So we have to make choices about what type of structure we want, okay? And as I've said, I've picked this particular architecture. Now, the hope is that through this course here, when you see me building this up, it gives you enough confidence to go ahead and possibly at the end of this course to come along and say, well, I don't really like this architecture. I want to go to have 3 registers. Or you might say, I only want to go and have 1 register. In which case you have to shuffle things back and forward an awful lot more. You might feel that you don't need any addressing modes. Or you might feel you need more addressing modes. You might feel you want more opcodes, less addressing modes, or more less opcodes and more addressing modes. So there's lots of different ways that you can design this, and they've all got pros and cons. They've all got things that are positive and negatives. So that's my hope with the course, that it gives you enough confidence to go ahead and pull this design apart and say, I'm not happy with this and I'm going to make it better. That would be perfect for me. So anyway, this is our architecture that I've chosen. Now there's one other thing that I've done here to make it even more general, and that is that in the previous 8-bit iteration, we only had I can't actually remember off my head, but only one of these register groups could be set. So we could, I think we could set RA and RB, but we could only enable RA. So I've adjusted it so we can enable and set both RA and RB. Okay, so I've done that just by adding in the complementary architecture here. So this little mux here, and also we've got our outputs here. So we've got our A enable, B enabled, A set and B set. So these are the outputs from our microcoded control unit, which control the flow of information through these last 8 bits. So if you think about what we can do then with this, any of these registers can talk to any of these registers. And we can set and enable any of the registers through these last 8 bits, because they all talk to one another. So we've got a really, really general purpose machine here that's excellent for learning, and that's the reason for going down this route. Now that's our basic architecture here that I've talked about. So what I'll do is I'll bring this back into line here, okay, and we can zoom out a little bit. Okay, now one thing will mention here before we head off, and I think I did mention it in a previous video, but I'll just reiterate it here. It's set up again because I want it really general purpose, so that we can set all of the registers here via the RA and RB. So we can set all of the registers via the instruction, and we can enable all of the registers, or almost all of the registers. There's a couple here we can't, okay. There's a couple that I had to cut out in order to give us space, okay. But I will note that, and it doesn't make a big deal of difference to us. But you can see here we can actually enable register RA and RB as well from the 8 bits, at least 8 significant bits of our instruction. So not only can we do it there, we can set and enable not all of the registers, but we can set and enable most of the registers from the microcoded control unit. So you can see the microcoded control unit comes up in here, and each of these lines get into each of these registers. But remember, we deliberately chose not to be able to set and enable the first lot of registers, R0 up to R5, and we did that in order to try to simplify the the spreadsheet or the microcoded control unit. If we'd added these lines into all of these other ones here, it would have extended the number of lines in our microcoded control unit by, well, I think actually with 1, 2, 3, 4, 5, 6, 2 to the power of 6, okay, and that would be that number 2, 4, 8, 16, 32, so it's 32. It would be 32 times bigger. The microcoded control unit would be 32 times bigger than we have at the moment, and that would be okay for the microcoded control unit, but it was difficult for me because I had to generate a spreadsheet that generated all of the ones and zeros. So I wanted to balance that out, and that was the balance that I came up with. Okay, so this is the balance that we came up with between a microcoded control unit, so the microcode is coming out through these lines, and a hardwired unit, and the hardwiring is coming out through the least 8 significant bits of our instruction through here and through these lines here. Okay, so that's me talked over that. Now, I'll talk over, just before we go on, a couple of other what I'll do is we can leave this video here for the moment, and in the next video I'll continue and we can talk over some of the extra registers that I've put in, and we'll talk over just a little bit about the addressing mode and how I set it up here within the design, which is quite simple, there's not much to it. So that's all for this video. Thank you for listening. I'll get you on the next video. Goodbye.